Welcome to the sixth video in the series AWS Solution Architect Certification. In this video, we are going to focus on cloud migration. Now let's take a look at our first question. A leading automobile company runs its web application on-premise. To reduce dependency on the on-prem infrastructure, it has decided to move its web and app server infrastructure to AWS on EC2 in an auto-scaling group. The MySQL database cluster will continue to be on-premise. However, the application is latency sensitive and the solution architects wants to ensure dedicated high bandwidth, low latency connectivity between the web app server on AWS and on-prem database. What is the best available solution for the architect to meet the latency requirement? So the key requirement here, as you can see, the web and app server are in an auto-scaling group on AWS, and that MySQL database cluster is on-premise. So it needs connectivity between on-premise and AWS, and it is highly sensitive to latency. So they need a dedicated high bandwidth, low latency connectivity. So this is the key requirement for this design. So now let's take a look at the options. So the first one is set up a VPN connectivity between AWS private link over the AWS private link between AWS VPC hosting the web app server and the on-premise database to meet the latency requirement, at the same time be cost effective. So what it is saying is that you establish a VPN connectivity between the on-premise and AWS. So that's a possible option. But the problem with VPN connectivity is that it will not be a dedicated network. So it will traverse over the public internet. The second thing is the AWS private link is not relevant here because private link is used for connectivity between AWS services which are hosted in AWS VPC to your VPC. So this option is not a correct one. So now let's look at the second one. Set up AWS direct connect link between AWS and on-premise data center. Dedicated network between the two can help achieve the latency requirement. So yeah, this is a good option. You can use the AWS direct connect. It provides you a dedicated network connectivity between your on-premise data center and AWS. So this can actually really help to reduce the latency and provide a high bandwidth network. So this seems like a good option. Now let's take a look at the other two options. Utilize the AWS private link, AWS private network to help set up a highly cost-effective and low latency network between AWS and on-premise data center. So as we discussed, AWS private link is connectivity between AWS VPC and some of the services like S3, DynamoDB. So that's where you use the private AWS private link. It is not for connectivity between on-premise data center and AWS. So again, this is not the correct option. Finally, set up a VPN connectivity over public internet between AWS VPC hosting in the web app server and on-premise database to meet the latency requirement, at the same time be cost effective. Yeah, this is one of the options. You can set up a VPN connectivity between AWS and your on-premise data center. But the issue with this is that you don't have a dedicated network, so it will traverse over the public internet, which can impact your bandwidth requirements. So this will not meet the latency requirements. It is going to be cost effective compared to the most likely to the direct connect, but that's not the it's asking for the best solution in terms of low latency connectivity. So that's why, although it's an option, but it's not the correct option. So the right answer for this one is option 2. Now let's look at the next question. A leading bookstore runs its web application on-premise used by users across the globe. The app server runs on the virtual machines and it uses Oracle DB. It has a lot of static content, mainly images and video, which give a preview of new books from upcoming authors. It has some issues with reliability and it wants to improve reliability of web application, at the same time reduce cost by moving to AWS. Which of the following is a good set of services for migration? Okay, so it's basically on-prem. It has a web application that it wants to move to AWS, the database, the Oracle, and it wants to move the web app and database tier to AWS, and also look at low cost solution on AWS. So now let's take a look at what are the options you have. And the other requirement is that you also have a lot of static content, mainly images and videos, which will be accessed globally, right? So let's look at the options. Use CloudFront for static content, EC2 in auto scaling with ALB, and migrate database to Aurora. Okay, so yes, this is a good option. So for static content, you use the CloudFront and S3. For dynamic content, you use EC2 with ALB. So yeah, this is correct. And migrate the database to Aurora. Yeah, this is definitely possible. You can migrate from a heterogeneous database from Oracle to AWS Aurora. So what are the things we need in terms of the tools? So use AWS application migration service. Yeah, that can help you move your virtual machines. So that's correct. Then you have the DMS, database migration service plus schema conversion tool for Oracle to Aurora DB migration. Yeah, so basically use the database if it is homogeneous from Oracle to Oracle or MySQL to MySQL to MySQL, then you use the DMS. But if you need to change the database engine, you can use the schema conversion tool. So this looks like a good fit, but now let's take a look at the other options. So again, use the CloudFront S3 for static content. Yeah, that's correct. EC2 and ALB for dynamic content. Okay, that works. And then migrate the database to Aurora. Okay, this is correct as well. Okay, now let's look at the tools for migration. Use AWS DMS SCT for app server migration and application migration for Oracle to Aurora DB migration. So yeah, this does not seem to be correct because DMS SCT is used for heterogeneous database migration and application migration service is used more for server migration. So yeah, this is not the correct option because the tools that highlighted here are not correct. Use S3 for static content with cross-region enabled, EC2 in auto-scaling with ALB, and migrate database to Aurora. Okay, so the problem here is that it is being accessed globally. So even if you enable multiple buckets with cross-region replication, it will still not solve your problem of low latency from accessing across the globe. So that means it might not be a good option. And you can enable CRR only, you can have S3 buckets only for a few regions. You cannot have it across all the regions in the world. So yeah, this is not a good fit. Finally, use CloudFront for static content, EC2 auto-scaling, and ALB to migrate the database to Aurora. Yeah, so this seems like a good fit. Now let's look at what are the tools that we have. Use AWS application migration service for app server migration. Yeah, this works. And then use AWS import export for Oracle to Aurora DB migration, which is not correct because you have to do the schema conversion. So for that you will need the SCT tool. Okay, so this option is incorrect. So that's why the first one seems the most appropriate one. Okay, so sorry for that. So the first option, the first one is the correct option, and this is not the incorrect one. Okay, great. Now let's look at the question 3. A global FMCG has embarked on a cloud-first strategy and set up a dedicated 1 Gbps AWS direct connect connection between AWS and on-premise data center. Solution architect has been tasked with migrating a data warehouse application with 80 TB in 7 days with incremental data generation of 1 TB. The AWS direct connect is running at 70% capacity. What is the most cost-effective solution to migrate the data warehouse application? So basically what is happening is they already have 1 Gbps AWS direct connect link between AWS and on-premise data center. So the solution architect has been tasked with migrating 80 TB in the data warehouse application with 80 TB data, and you have to migrate in 70 days. The direct connect is already being utilized at 70%. So you already have the 30% bandwidth that is available for 1 Gbps AWS direct connect. What's the most cost-effective solution? It's also generating 1 TB of data incrementally, right? So clearly you cannot migrate all the 80 TB through this 1 Gbps link because there's only 30% capacity available. So what you will do is you need to look at an offline solution because it says that it needs to migrate in 7 days, right? And then the incremental data that you have, you can migrate that through the direct connect that gets generated. Okay, so now let's take a look at the options. Use AWS data sync to transfer the data between on-premise and AWS utilizing a direct connect. So yeah, which doesn't seem to be possible because you have 80 TB and you have only 30% capacity. So it might not be able to transfer all that data in 7 days. So this might not be a right fit because there is a limited capacity in the 1 Gbps AWS direct connect. Next one, use Snowball to transfer data 80 TB and use data sync to transfer the incremental data that gets delivered during the delivery of the Snowball. Yeah, this seems a good option. You can for AWS Snowball you can transfer up to 80 TB and it takes about 1 week to transfer the data. Once you have loaded the data and sent to AWS, it will take about 1 week. So that meets the requirement. The second thing is you can actually use AWS data sync to during those 7 days you can use one TB transfer through the data sync with the capacity that you have available with the direct connect, because once you ship it takes 7 days. During those 7 days you cannot transfer the new data, so that you can do through the direct connect. So yeah, it seems to be a good fit for this question. So now let's take a look at the other options. Use AWS Snowcone to transfer HTTP transfer with AWS Kinesis data stream to transfer the data, the incremental data. Okay, so now there's an issue with this because Snowcone is usually used only for up to 8 TB of data, so it won't be able to fit in here. And Kinesis data stream is also not really a data transfer solution for transfer from on-prem to AWS. Most likely a data sync is a better solution, so this doesn't fit in here. The AWS Snowcone use AWS Snowcone to transfer the data of HTTP along with the AWS Kinesis data stream transfer incremental data that gets okay. So I think I have the same option here. So it doesn't. It's again not a good fit. Okay, I will update this fourth answer. Third and fourth seem to be same. Okay. Now let me just move to the fourth question. So the correct answer is the second one. Now a global fashion brand wants to run a photography contest allowing users across the globe to upload and download the photograph in S3 bucket in the US East region along with CloudFront to reduce the latency for the end users. The brand has been subject to DDoS and other security attacks in the past, impacting the image of the brand. The solution architect has been assigned to look at the security services that can be help mitigate the challenge around security. Which one of the following services can help the fashion brand? Okay, so basically you can see that it is allowing users to upload and download photographs in an S3 bucket in the US East region, and then it uses the CloudFront as well. So it has had DDoS attacks in the past, and it wants to mitigate and see what are the best solution architecture around security that can be used. Now let's take a look at the options we have. Utilize the AWS Shield and Advanced Shield to mitigate against DDoS attacks. Use WAF to protect malicious IPs. Common attacks such as SQL injection, cross-site scripting, and enable encryption of the S3 bucket. So this seems like a good fit. Yes, Shield and Advanced Shield help you against DDoS attacks. WAF helps you protect against known malicious IPs. Common attacks such as SQL injection, cross-site scripting. And then you can also enable encryption and the S3 bucket. So this seems to be like a good fit to meet all the security requirements that we have. Then you have the utilize AWS Shield and Advanced to mitigate against DDoS attacks. That's correct. Use Amazon Inspector for scanning potential security vulnerabilities and enable encryption on the S3 bucket. So you can see here Amazon Inspector. Amazon Inspector is not used for S3. It is only available right now for EC2 instances. So it does do security, it does do scanning on the potential security vulnerability and network reachability, but it is only for the EC2 and not S3. So due to that, it is not the correct option. Utilize the Amazon Guard Duty to mitigate DDoS attacks. Use Amazon Inspector for scanning potential security vulnerabilities and enable encryption on S3. So yeah, so this is not correct. Amazon Inspector, as we just discussed, Amazon Guard Duty is more an automated threat detection which would work on the logs such as VPC flow logs, DNS logs, etc., and then provide you some insights into security vulnerability. So again, this is not relevant here for S3. Then finally, again, use Amazon Inspector for mitigate against the DDoS attacks. Use WAF for scanning potential security vulnerabilities. So that is correct. Common attacks such as SQL injection, cross-site scripting, and enable encryption bucket. So this is correct. Enable encryption. Use WAF for SQL injection, cross-site scripting. But Amazon Inspector does not mitigate against DDoS attacks, as we discussed. It's only for EC2. So this is not the correct one. So you have the first one as a correct option. That's pretty much it. Thank you very much.